Hey, hi, and welcome back. I hope that you are enjoying the layout creation process. So in previous video, we completed the component placement. We placed all the components on the layout editor, and we also discussed what component should be placed at what location. Okay, so all those questions were answered in previous 3 videos. Now from this video, we are actually going to start with the layout design. So we are going to connect all the components with each other. Okay, and I hope that you will enjoy this particular procedure. Alright, so now let's start with this video. So in last video, we completed the layout till this point. Let me maximize this particular window. So we completed the layout, and I told you that I will arrange all the designators of the components in the appropriate manner. And you can see I have arranged all the designators on this layout, and I have placed them at the appropriate location. Now, first of all, let me show you how exactly our PCB is looking. Okay, so I will go to the manufacturing window and let's see how exactly our PCB is looking. So I will just maximize this window and let's see how our PCB is looking. So that's how basically our PCB is looking. It's looking nice, and we have placed all the components at the right location. Okay, so motor driver section is here, then the power supply section is here, RGB LED section, then 7-segment display section, switch, user input switch, potentiometer or the preset section, then programmer/debug section, and this is basically the controller section. Okay, now let's start with the layout design, and let's start from this particular point. As I told you, we are actually going to power our system from this point, as this is a DC female jack, and we are going to get the power at this point. These are actually the 2 pins from where we are going to get the 12 volt. Okay, so from here the 12 volt will come, or the current is going to flow like this through this diode, then from these capacitors towards the input pin of this IC. Now as I told you, when we discussed the layout editor in the module 1, I told you that we use this particular option, which is route air wire, and we simply connect these wires like this. Okay, and we do the connection like this. Now here the question comes, what should be the width of this particular track? Okay, so the current is actually going to flow like this, so there should be, we have to use the appropriate width. So the question is, what should be the width of that particular track? I hope that you remember when we did the current calculation for our block diagram. At that time we calculated the input current, or the current which is going to flow through this diode then towards the input pin of this 7805 IC. We saw that the maximum current which our system is going to drain at 12 volt, it's going to be 451 milliampere. Okay, so we need to choose the track width in such a way that the width of the track should be sufficient in order to pass that particular current. Now again the question comes, how we decide what will be the width of that track, or what will be the width that will be supported by that particular current. So for that, what you have to do, you have to go to online website, and there are actually multiple websites from where you can get the width of the track for a specific current. Okay, so you have to go to those websites, and you just have to enter the current for the track, or the current which is going to pass through that particular track, and that particular website or that calculator is actually going to give you the width of that track. Okay, so same thing we are going to do now. I will take you to online track width calculator, and there we will see what should be the track width for this particular path. As I told you, the current which is going to flow at 12 volt through this track, it's going to be 451 milliampere. So we need to select a suitable track width in our design. Okay, I generally don't go for the online website to get the track width of the track. Instead of that, I actually use one software which is called as Saturn Toolkit. Okay, so there are actually a lot of options in that software. You can calculate the track width, you can calculate the resistance for a track. So there are actually multiple features in that particular software. But as we are getting started at this moment, that software is actually little bit complicated, so that's why I have not included that software in this training. And straight away I will take you to the online website, and there I will show you how to calculate the track width. Okay, but you can explore that particular software. It's really good software. I have been using that software for a long time now, and whenever I have to design multi-layer PCBs like 4-layer, 6-layer, 8-layer or high-speed PCBs, I most of the time use that particular software to get the different parameters for the PCB. Okay. So now let's go to the online website and let's see how to get the value of this particular track. So you just have to search for online trace width calculator on the Google and you will get multiple options or you will get multiple links. So you can select this particular one, which is from DigiKey. So I'm just going to select this one. So this is basically the calculator from the DigiKey. I will just select exit here. So this is basically the calculator from DigiKey, and you just have to enter the current here and rest of the parameters which I will show you in a moment, and you will get what should be the width of track that you have to use. Okay. So it's going to give the width of that particular track which will support the X amount of current. Now, as I told you, we need a track width for a current of 451 milliamperes. So I'm just going to write here 0.451, and after that I will give enter here, and you make sure that this unit is actually in amperes. So this is basically 0.451 ampere, which is 451 milliampere. Okay. So you have to write or enter the current rating properly. So this is basically the amount of current which is going to flow through the track. And after that, the next option is thickness. So here we need to select the thickness of the copper which is there on top of our PCB. So when I will show you how to order the PCB, okay, from the online manufacturer, there you will get to know why I am using this particular value. But at this moment, you just consider this value which I am entering here. And the unit is going to be micrometer. Okay, so the thickness is going to be 35 micrometer, or it is also called as 35 micron. Most of the manufacturers which manufacture the PCB, on their website you will find this particular value as a default value for the thickness of copper which will be there on the dielectric. Okay, so that's why I am entering this particular value, and this value is also called as finished copper thickness. So we are going to use a PCB on top of which the thickness of copper is going to be 35 micron. And we need to include the same value here, and it's asking the same value here, which is what will be the thickness of copper on the PCB. So we have entered that value 35 micrometer. And after that, the next one is temperature rise. So I'm just going to include here value as 10. So I will just include 10 here. And later ambient temperature, let's consider as 25 degrees Celsius. So I will enter the temperature as ambient temperature as 25 degrees Celsius. And length of track, we are actually not sure. So even if you don't include the length of track, it's completely fine, because the trace width is actually independent of this length of track. So even if you choose different length, it's completely fine. The track width is actually going to be the same. So if I enter, first of all, I will tell you this is basically the required trace width. So we need to select this particular trace width in order to pass this much amount of current. Okay. So now if I enter trace length as 10 inches, and if I give enter, you will see that rest of the parameters are actually changing, but this particular parameter will not change. The reason is the trace width of track is actually independent of length. So I will enter 20 here, and you can see rest of the parameters are actually changing, but not this required trace width parameter. So this much trace width, which is of 10 mil, it's actually enough to pass this much amount of current. Okay, so this does not mean you can straight away select this particular trace width in your design. You can actually go for even a higher trace width. It's fine. We just have to make sure that we are not selecting the trace width less than this one. Okay, so this unit is actually in mil. Generally, most of the people who design the PCB or layout design engineer, they're actually going to use this unit mil, which stands for milliliter per inch. Yeah, it's milliliter per inch. Okay, so that's basically the extension of that unit. Now, as this particular unit is little new to you, so I will select here millimeter, and from this you will get the idea. Like 0.2 millimeter is actually 0.26 millimeter is actually the trace width, and this much trace width is actually minimum trace width which is required to pass this much amount of current. So when you will design multiple designs, over the period of time you will get the idea what trace width is enough to pass what current. But still, most of the time you have to use the trace width calculator like this, or you can go for the Saturn PCB toolkit. Okay, so from here we get to know that we need to select a trace width of 10 mil, and I'm going to select a trace width even higher than this one. Okay, so now let's go to our layout editor and let's select the trace width as or greater than this particular value. Alright, so we are on the layout editor now, and let's select the trace width. First of all, I will just rip up this connection, and let's go to the route airwire, and after that you need to go here grid, and let's change the unit to mil, and then after that I'm going to click on OK. So with that we are getting now here this particular width is actually in mil, so we need to select here the width of track greater than 10 mil. So you can go for 20 mil, you can go for 25 mil, you can go for 50 mil. It's up to you, but you just have to make sure that the track is not much bigger so that it should not create problem for rest of the connections. Okay, so you have to select a track width greater than 10 mil. So let's get let's take the track width as 50 mil or 25 mil. Okay, let me select 50 mil, and after that I will give enter. And now when I will route, you can see the width of this track is now 50 mil. Okay, so that's how basically we increase the width of the track. All right, and this track I will pass through this capacitor, then through this capacitor, and then through this towards this 7805 IC. So that's how basically the current is going to flow. All right, and I'm going to do the same thing on the output side. So from here the 12 volt will come, it will go through the diode, the current will flow like this, and if there is any noise on this line, then it will be filtered by these two capacitors. The 12 volt will come towards this IC, and on the output side we are going to get 5 volt. So straight away I'm just going to do the connection, and this is basically the output capacitor, and from here we are going to get the 5 volt. Okay, so I will just stop this track at this point, and these are actually these are the current limiting resistor components. So I will just split the screen. So these are actually the current limiting resistor, and so this is basically current limiting resistor and the power LED, and here the current which is going to flow through this resistor, it's going to be less than 20 milliampere, right? When we did the calculation, I told you how to get the value of current limiting resistor. So we saw that the track width of 10 mil is actually capable of passing 0.451 amperes of current. But in our case here, the current is just in milliamperes. So we can go for a track width less than 10 mil also, okay? Or even if you go for a track width of 10 mil, it's completely fine. So from here, I'm just going to route this part with a track width of 10 mil. And I understand that this mil unit is little bit complicated for you at this moment to understand. Your brain might not be accepting this particular unit, but you get habitual to this particular unit because most of the people in industry actually use this unit while creating the PCB. Okay, so at this moment I understand your brain must not be accepting this unit, but it's fine. You have to tell your brain, okay, I have to use this unit while creating the layout. All right, so that's the point. So here we have selected a track width as 10 mil. So we got the 5 volt here, and now let's see where that 5 volt is going. So I will just go to this point, and this 5 volt is actually going towards this IC, microcontroller IC, then it's going towards this motor driver IC, and also it's going towards this 7 segment display driver IC. Alright, so we are done with the layout of power supply section, and in next video we are going to complete the layout of 5 different sections. Okay, so I will see you in the next video now.